Welcome back to this class. In this class, we'll consider metals in a simple way first, before we treat it in a broader way in subsequent video. But right now, we are only going to consider the definition and some general properties, both the physical and the chemical properties. So let us start with the definition of metals. So the common definition of metals is that metals are elements that ionize by losing electrons. So when metals lose electrons, they become positively charged. Why do they become positively charged after losing electron? This is because in every atom, there is the same number of proton, which is positive charge, and electron, which is negative charge. So when these two positive and negative charge, when they balance each other, atoms become electrically neutral. And that is why every atom is electrically neutral. So this is the reason why every atom, before undergoing ionization, they are always electrically neutral. Take, for instance, an example of a metal, sodium, for instance. So the atom of sodium contains 11 protons in the nucleus and then 11 electrons outside the nucleus, revolving around the shells. So the sodium atom has 11 protons and 11 electrons. So now when you put the same number of positive charge together with the same number of negative charge, of course, the result will be 0. Just like adding plus 11 minus 11, we are going to get 0 at the end of the day. So this is responsible for the reason why the neutral atom of sodium is neutral. So it's electrically neutral. Sodium in its free state without ionization or before undergoing ionization, its atom is neutral. But after undergoing ionization, since sodium is a metal, it has to lose an electron. So if sodium loses one of its 11 electrons, that means it will be deficient of electron. So in that case, we are going to have 10 electrons, which means that the number of protons is now more than the number of electrons. So after ionization, when sodium has already lost one electron, so that means we are going to have 11 protons and 10 electrons. Putting these together, the result will give us +1. That is why the ion of sodium is always +1. So here is the symbol for neutral sodium, Na. You can see it's carrying no charge. And this is the atomic structure of neutral sodium. This is simple atomic structure. Now, this central circle is the nucleus. This is the central nucleus, which contains 11 protons. And you can see a cloud of electrons revolving around it. The first shell contains 2 electrons, and the second shell contains 8 electrons, 2 plus 8 giving us 10. And the last shell contains only 1 electron, so making 11 electrons. So this is neutral. This is sodium before undergoing ionization. Now, on the other hand, when sodium undergoes ionization, it doesn't remain the same. So consider this. This is sodium ion. This is how we represent it. This is symbol for sodium ion, Na+. Why? Because we have one electron. It's deficient of 1 electron. So it has 1 proton left. That's why we have +1 here. Now, this symbol or this diagram represents sodium atom. Now, after losing electron, we have lost the outermost electron, and then we have 10 electrons remaining. So this is how we represent sodium ion. And the simple ionic equation is given as follows. So this is the ionic equation. This is neutral sodium. It loses 1 electron and becomes sodium ion. So this is the lost electron. So generally, every metals, when they lose electron, we can represent them with this simple ionic equation. So we have M, which represents a general metal. It can be sodium, it can be magnesium, it can be potassium, it can be calcium, etc. So N represents the number of electrons lost, and this is usually the group that the element belongs to, because the number of electrons an element can lose depends on the group that it belongs to. So if it belongs to group 1, it can lose 1 electron. If it belongs to group 2, it can lose 2 electrons. If it belongs to group 3, it can lose 3 electrons. So sodium belongs to group 1, that's why it's losing only 1 electron. So then the ion becomes Mn+, meaning that N is the number of lost electrons. We can apply this equation to do for 2 or more other metals. So, but don't get confused. This equation can be written in another way. So this is another way of writing it. Don't get yourself confused. This is just a process of collecting like terms. This is just a process of moving negative to the other side. We can see that the minus Ne minus is moved to the other side to become positive. So whichever way between the two methods we can choose, we can write our ionic equation. So let's apply this to some other elements. So these are other examples of metals when they undergo ionization. Consider the first one, which is potassium. Potassium undergoes ionization by losing one electron. Why? Because it belongs to group 1. So it's capable of losing just one electron. So, and it becomes potassium ion, K+. Now, magnesium can lose 2 because it belongs to group 2. So it's capable of losing 2 electrons to become magnesium ion, Mg2+. Now, calcium belongs to group 2 as well. It's capable of losing 2 electrons to become calcium ion, Ca2+. Now, aluminium belongs to group 3, so it's capable of losing 3 electrons to become aluminium ion, which is Al3+. So other elements or other metals that can be confusing are those transition metals that have variable oxidation states. Those metals that have different, they have more than one valency. So this one too is not a problem. Just use each one of the valencies to form the ionization equation. For example, copper, we have copper 1 and copper 2. So consider these two equations below. So these are the two ionic equations for the two coppers. So for copper 1 is capable of losing 1 electron. So it becomes Cu minus E minus to give us Cu plus. So when copper 1 loses 1 electron, it becomes Cu plus. Now, this is the ionic equation for copper 2. Copper 2 is capable of losing 2 electrons. It becomes Cu2 plus. So these are the ones that can be confusing. Now, we also have, among the transition elements, we also have iron. Iron is Fe, ferron. So now these are the ionic equation for the two kinds of ion that we have. We have ion 2 and we have ion 3. So when ion 2 undergoes ionization, it's capable of losing 2 electrons to become Fe2+. This is the ion 2 ion. Then this is ion 3 ion, because ion 3 is capable of losing 3 electrons to become ion 3 ion, that's Fe3+. So this is just a simple way of representing a ionic equation for metals. Thank you. So now let's consider the periodic table to see where metals can be found in the periodic table. So this periodic table that we have here is very colorful. So generally, those ones that are painted red, so that is, those elements that are found in red box are metals. Why those ones in blue box are non-metals? Why those ones in yellow box are metalloids? So now, generally, the periodic table is divided into 4 blocks. We have the block S, which contains group 1 and 2. Then we have the block P, which contains from group 3, 4, 5, 6, 7, and 8. Then we have the block D, which is between group 2 and group 3 in the periodic table. So all the elements within this place are known as transition metals. So then we have the block F, which are the inner transition metals. So they are separated out. They are known as the lanthanide and actinide series. This first row is the lanthanide series, and this second row are the actinide series. So this group 1, excluding hydrogen, though hydrogen belongs to group 1, but hydrogen is not a metal. Starting from lithium down to francium, they are all metals, and they are known as alkali metals. So they are called alkali metals because they form alkalis in water. So elements in group 2, starting with beryllium down to radon, are also metals. So they are called alkaline earth metals. So why? Because they are found in the earth crust, most of them. Examples are magnesium, calcium, and so on. So looking at the third group, which is group 3, so this belongs to block P. So you can see that the first element in the group is not a metal. So that's boron. Boron is a metalloid. So starting with aluminium, gallium, down to this, they are all metals. So then other ones from group 3 and above, they are non-metals. Even though if you look down each group, we are having some metals inside it. So because this periodic table is a mixture of both metals, non-metals, and metalloids. But metals are more than other ones. So then coming down to block D. This block D elements are specially called transition metals. So they are specially called transition metals. So they are studied separately. Finally, we have the block F down here. These block F elements are called the inner transition metals. They are called inner transition metals. So they are the lanthanide and the actinide series. They are brought out from the lanthanum series and the actinium series. So the lanthanide series is atomic number, starting from atomic number 57 up to atomic number 71. So that's a group of 15 elements, so called lanthanide series. Similarly, the actinide series is also a group of 15 elements, starting with actinium. Starting with actinium, with the atomic number 89 up to 103. So those are the actinide series. So it's also a group of 15 elements. All of those ones are metals. You can see metals can easily be identified on the periodic table. Thank you.